Good morning, Year 4, and welcome to today's maths lesson. Today we are carrying on with fractions, and we're carrying on with our equivalent fractions that we looked at yesterday. Remember, an equivalent fraction is a fraction that has the same amount, same value. Okay, it means the same thing. The analogy I gave you in the last lesson was bonjour and hello. They both have the same meaning, just in different languages. Okay. Before we get started though, let's get ready to learn. Let's warm our mathematical brains up, and here's some questions for you to have a go at. Pause the video now, have a go at those, and then come back when you're done. Off you go. And let's get started then with question 1. What fraction of the shape is shaded? You can see there that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks, and that 1, 2, 3, 4, 5 of those are shaded. 5 equal parts of 10, or half. Okay, 5/10 of that bar model is shaded, or half of it is shaded. It's the same thing. 5/10 and 1/2 are equivalent fractions. With the second part, you had lots of calculations that involved similar numbers. Okay, so we know 3 lots of 5 is 15. Well, does that not mean 5 times 3 is 15? And that 15 divided by something equals 3? Well, that something's going to be 5. So hopefully you spotted the pattern here, okay, that we were creating different ways of setting out that calculation. You can see that the way that 15 is related to 5 and 3, something that's going to be useful this lesson. And in part 3, how many 16ths are there in 1? Well, we know from what we've learned about fractions so far that 1, our fractions are equivalent to 1 when the numerator equals the denominator, okay, when they're the same. So if we've got 16ths, we need to have 16 of those to make one whole. Right then, let's get on with some learning. I'm going to show you a number line now. I'm going to split that number line in half. Up to halfway, obviously, is 1/2. And all the way over to 1 would be how many halves? 2 halves. 2 halves is equivalent to 1 whole. It's the same as. If I had that same number line, you can see there it's the same size, and this time split it into quarters, you can see there that each of these intervals is worth 1/4. I could break that up then and show 1/4, 2/4, and 3/4. If I went all the way over to the from one side of the number line to the other, I'd show 4/4. 4/4 is the same as 1 whole. 4/4 is equivalent to 1 whole. The numerator matches the denominator. If I now showed you, well, what fraction am I going to show you now? How many equal parts have we broken it up into? You can see there that I've broken it up into 3 equal parts. Got 1, 2, 3 equal parts. So it's showing thirds. Got 1/3, 2/3. If I went all the way across, I'd have 3/3. One more number line now. Now I know without counting that the fractions shown here are going to be in some way related to thirds, because I can see that that line lines up really nicely with that one, and so does this interval here with 2/3. Remember, these lines are called intervals. And I can see that they match up, so maybe they're related. Well, hopefully you've counted that there are 9, so you can see the 9ths there. Okay, and you can see that a whole would be 9/9. You can look at what 1/3 and 2/3 are equivalent to. What have you noticed there, Year 4? Write down something on your paper that you've noticed that all of these have got in common, all those number lines on the screen. I'd be interested to see what you find. Let's move on. So, if I've got quarters, and each of the blocks in this bar model is worth 1/4, here I've got a number line going from 0 to 1. As I move across this number line, you can see how, if I've just moved up to here, I've got 1/4. If I add another, I'd have 2/4. If I added another, I'd have 3/4, and all the way across I'd have 4/4, or 1/2. I'm now going to split all those quarters in half. How many equal parts have I got now? I've got 1/8. Now, the bar model and the number line haven't changed in size, so can you see what 1/4 would be equivalent to? It'd be equivalent to 2/8. 2/4 would be equivalent to 4/8. 3/4 would be equivalent to 6/8. All the way across, 4/4 or 1/2 would be how many eighths? Well done, I heard you over here. 8/8. Now I've split them into 12ths. How many 12ths would be the same as 1/4? Would be equivalent to? Well done, it'd be 3. 3/12 is equivalent to 1/4. If I added another 3/12 on, I'd have 6/12 is equivalent to 2/4 or half. How many 12ths would be equivalent to 3/4 then, year 4? It'd be 9/12. Well done. Now, let's move those up there and let's split these up. You can see that each quarter now is split up into another 4 sections. So I'm going to have 4 quarters, each one split into 4. So I'm going to have 4 lots of 4, and that is, it's quick math, 16. So each one now is going to be 16ths. Okay, and you can see there that 1/4 is the same as, or is equivalent to, 4/16. 2/4 would be how many? Well, it'd be double this amount, so it'd be 8/16. 3/4 would be how many? Well done, if you said 12/16. Super duper effort. Now, what I've done now is you can see all the number lines matched up, and you can see how I've got 1/4 on all of them. And you can see that 1/4 on the top one was equivalent to 2/8. On the second one, it's equivalent to 3/12. On the bottom one was equivalent to 4/16. So all 4 of those fractions are equivalent. I wonder if you can spot a pattern. Can you spot a pattern there between the numerators and the denominators? Can you think of any other equivalent fractions in that family? Look at the pattern with the numerators and my denominators. Can you think of any more? Once you've done that, year 4, pause the video and go and have a go at questions 1 to 3 on the worksheet. Off you go. Okay, back to our lesson then. We're doing really well with these equivalent fractions. What have I broken this line up to? You can see that there are 1, 2, 3, 4, 5. We always count the last one. 5 intervals there. There's gaps, isn't there? 1, 2, 3, 4, 5 gaps. So I've got fifths, and 1 would be 1/2 would be 5/5, wouldn't it? Okay. Now, if I was to split all of those in half, what would each one be? Well done. There'd be tenths. I'd have 10 equal parts. And you can see there that 1/5 is equivalent to 2/10. You can also see that 4/5 is equivalent to 8/10, and so on with others as well. Now, if I had fifths and I split each one into 3, what fraction am I going to create now? Think back to what we did at the start of the session. What fraction are we going to have now if I split each of these fractions, each of these fifths into 3, and I did that 5 times? I'd have 5 lots of 3. What's that going to be? Well done if you said 15ths, because each section here will be 3 of, and there's 5 sections, 3, 3, 3, 3, 3. 3 times 5, 15, or 15ths. And you can see that 1/5 is equivalent to 3/15. 3/5 is equivalent to 9/15. Now, you know I like puzzles. I really like this puzzle. But puzzles are they're all exactly the same. They have steps. You follow the steps, you go one step at a time, you find a solution, and then we move on. There's no question at the moment. Just think about what fraction is where that blue dot is. Think about that first. 5/12 is halfway between the blue circle and the star. Draw an arrow to where the star is on the number line. If you want to pause the video now, because the question is what fraction is represented by the star. If you want to pause the video now and have a go at this, okay, you're doing well. It's a tricky one, this, but I think you can do it. You think about whereabouts that star is going to be and whereabouts 5/12 would come up on that line. Okay? Right, so let's go through it then. It says that 5/12 is halfway between the circle and the star. Well, let's put 5/12 on, shall we? These intervals were at quarters. Hopefully you spotted that the blue circle was at a quarter. Now, whereabouts would 5/12 be? Well, we need to break it into 12s, don't we? Okay, so let's do that then. Let's break up into 12. Whereabouts would 5/12 be? I know 2/4 is equivalent to a half, and a half is equivalent to 6/12. So this one here must be 6/12, which means this one here is 5/12. So it's going to be there, isn't it? Now, 5/12 is halfway between the circle and the star. Well, if the circle's here, and 5/12 is here, and 5/12 is halfway, then the gap on the left-hand side is going to be the same as the gap on the right-hand side. So here is where the star is going to be. And what fraction is that? It's not 2/4, it's gone past 2/4. But you can count it up in 12s. Well done if you said that the star was at 7/12. Like I said, problems just about finding a sequence, taking it one small step at a time. Okay? Right, year 4. Great work today. Have a go at the rest of the worksheet. I can't wait to see what you've done. Bye for now.